Well, welcome everybody. Thank you for joining us. I'm really excited for today. We've got Danilo from Fifth World, who is the Director of Data Solutions, joining us today to talk about leveraging data for regenerative land design. Um, I could try to do a good job at introducing him, but who could do it better than him himself? So let's go ahead, Danilo, hand it over to you. And why don't you introduce yourself, tell us a bit about yourself, and then we'll get things rolling.
Okay, awesome. Thank you, Ben. Yeah, so I am Danilo. I am from Uruguay. I'm a software engineer, and yeah, I got interested into permaculture and ecology, I would say, maybe 15 years ago. And I moved to a property to start my own project. I think 11 years ago. Um, and at that time, I got really involved in trying to apply what I have studied, software engineering, um, to um, projects to improve the uh, environmental things here in Uruguay, but also trying to help permaculture designers with tools for doing that work. So yeah, long story short, I started working at Fifth World three years ago, and have been in this journey of building tools for designers, for landowners, which is really really exciting. Like I really love to do this. Um, so yeah, it's really my dream job, I would say, to be able to use software and apply it to trying to make things better for the planet, for the people. So yeah, today I will be talking about data for regenerative land design. And that has been the focus of the data solutions team at Fifth World. And yeah, so I will start the presentation and let me know if you have any questions, and we can also discuss at the end. Also, thanks to Jason and Adrian from our team for joining today. It's awesome to have you here. Yeah, so why do we want to design land? Probably this is all of you have answers for this, but the reality is that our culture, the standard thing is to not worry too much about designing the land, or maybe designing it, but without um, taking into consideration all the things that should be considered, specifically thinking about the long-term um, well-being of the people and the ecosystem. So we think designing land allow us to create systems that are more than sustainable. So they are regenerative, also resilient, so they can tolerate impact and adapt to it, but also anti-fragile, so they can even benefit from some kind of impact. And that's the case mostly for nature and living systems. I saw some interesting discussions in the Discord channel about that, which I hope to join more, to engage more actively yeah, in the new year. And also, very important to support both human and ecological well-being. I think we all want uh, our well-being and for our families and close communities, and also for the whole uh, for all the creatures being part of the ecosystem. So I really like this quote from David Holmgren. So he says traditional agriculture was labor intensive, industrial agriculture is energy intensive, that's the norm. And permaculture systems are information and design intensive. And that's our approach, I would say. Okay, so can we design anything anywhere when we are talking about land? So we know that the limit when you design a project, a land regeneration project, a permaculture project, we know that the limit is our imagination, but it's also true that we can't do anything. It really depends on these three things. So our vision for the project, our values, so basically how we want to get there to the vision, which is also important, and the thing we will be focusing now, which is the resources. So what resources do we have? Both like material, financial, um, natural, um, skills. So all these has to be a combination, and we can like really to make a project happen. We need to find the intersection between all those things for it to work. So what I want to say with this is that specifically talking about the natural part and the natural resources is that we really have to design our project having in mind what this land want to be. So we need to understand what we want the project to be, but also what's the natural trend for that land. Where is that going if we weren't there, if we were not working and having an impact there? Where does that natural ecosystem would go? And understanding that would help us really work with nature instead of trying to fight with the natural trend of that piece of land. So this is coming from a book, the Building Your Permaculture Property book, which is really gives a very easy to understand process to design land. And it includes these 5 steps. So the first step is to clarify your vision, values, and resources. So that's really important. It's really probably one of the most important pieces to really write down what you want to do and agree with other stakeholders of the project. So that's the first step. But the second step is to diagnose the resources for strengths, weakness, opportunities, and threats. So that is really getting all the data we can about the property, about the land, about the area. Then we can design. After we have done that work, that's the moment we can start saying, okay, I want to build a house in this place, the greenhouse in this other place. I want a pond, access roads, those kind of things. Then we can implement after designing. And the last step is to monitor because many things will not work as we expected. And so we need to be monitoring ourselves and the land to see what's happening and where the project is going. So, and then this is like a loop, right? So this can start again because like as humans, our mind can change and our vision can change. So also some characteristics of the uh, property can change. So we need to keep looping on those steps. The 2 steps that we will focus now are the 2 and 5. So basically the data gathering, because we are really trying to think about land design as a data-driven process. So here is where we use GIS systems to really help do this work. Probably everyone is familiar with GIS, but GIS means Geographic Information Systems. So it's basically software to manage maps, locations, and different geographic operations. A very basic but useful GIS software is Google Earth Pro. So that's really a really great software in the sense that it's easy to use and you can bring a lot of information there. Actually, that's one of the tools we use because we generate data that can be accessed through Google Earth, and that's pretty user friendly. There are many other GIS software options. One that we use internally is QGIS, which is a pretty advanced tool, really powerful tool, open source, really cool. But the thing is that with any of these software tools, we can start working with maps and creating different layers of data that can really help diagnosing and monitoring our projects. So we create the tools we create are to help, as I said, are to help land designers, but also like sometimes it's professional land designers, sometimes it's like do-it-yourself land designers, basically anyone trying to take care of land and trying to consider all these characteristics to make a good work of design and implementation and monitoring. So yeah, so the product we have launched very recently that adds all the work we have been doing the last 3 years is called Regen Tracker. And I will be talking about the product and about the different features, and also will mention some other projects that are really interesting for folks already working on regeneration projects, already living in these kind of projects. There are many cool things happening at this moment. Like there's a lot of open source projects, open data, citizen science projects. So I will mention some of those because yeah, it's really an exciting field at the moment. These are the features we include in our software. I try to organize it using the scale of permanence. It's not very accurate. It's like just to give an idea, but we are trying to cover the whole scale. And how this is organized is that the things that take more time to change and energy to change are at the top right. And then the things that are easier to change and take less energy, but also are less permanent, are at the bottom left. So to give an example, climate is something really hard to change. It will take a lot of energy to do it. On the other side, soil is something that, at least topsoil, is something we, in a short period of time, we can improve. So yeah, don't take this very seriously, but it's basically a list of the features between climate and soil that we are including in Regen Tracker. So we include things like energy assessment for renewable energy opportunities, topography maps, landscape health monitoring, which is something really cool I will talk about later, pro assessment, which is also a big set of layers that we will discuss later, biodiversity and soil. So I will start talking with topography. This is actually the product we have been offering for the longer time, many years now. So we create these topography maps that can be accessed through Google Earth or now through the web, including hill shades, contour lines, aspect, slope, slope direction, drainage networks, also river water catchments. So many different layers showing the shape of the land And I will show some examples. This is from Google Earth. These are the contour lines. This is from a project I was just checking yesterday. And this, for example, I guess everyone is familiar with contour lines. Is basically a line at the same level. So if you walk through the line, you won't go down or up. You are going just at the same elevation all the time. And this is the fundamental layer of topography. Land designers look at these maps and they really get everything, understand everything. So yeah, this is really helpful to understand the shape of the land, but also the different elevations, the difference in elevations from different points. It's good to choose how to build the roads, and many other things. But yeah, so having a good contour map is essential for any regenerative project to really understand the shape of the land. We also have this kind of aspect maps where you get to see the orientation of the slope. So with this, you get to understand which parts are more sunny or less sunny. So with this, you can decide, okay, maybe if I am in a place that's not very hot, very warm, I would choose if it's a northern hemisphere, I would choose the south aspect area for the garden, for example. If you are in a very warm area like myself in Uruguay, then I probably, for the summer garden, I probably would choose something different. We also have slope. So with this, you can see the percentage of the slope of every part of the land, and you can decide. There are some guidelines for what you can do depending on the slope. So, for example, very high slopes are not good for gardens or for any type of agriculture because of the erosion risk. So there in the map, I am only showing the slope higher than 27%. So, sorry, 27 degrees. So that shouldn't be used for agriculture, but it could be used for forest probably. So yeah, that's one of the other basic essential GIS layers. Then we also get to understand how water moves on the land. So the blue lines are like the streams, depending on how much rain we get. But you get to see where the water flows, and the arrows also show that. And then the green lines are I don't remember the English term for that, but basically at one side of the green line, the water will go into one catchment, and then at the other side it will be another catchment. So you get to see, for example, if you want to build a pond, you can see what's the size of the catchment. So you can start calculating how much water you will have depending on how much rain you have, which is also something we provide rain precipitation data. So yeah, these are the basic topography maps. Maybe you are already familiar with this, but this is really an essential piece of data for land design. The other essential piece of data is climate. So here we include temperature, clear sky insolation index, so basically how cloudy or clear the sky is, precipitation, frosts, insolation, yearly and seasonal windroses. So I will show a few examples. This is temperature, and this is using data from the NASA, from a model they have created. So you can really say, I want the data for these coordinates, and they will give you the data for the last 30 years, and you can get daily data, which is what we use to get the information with a high degree of detail, I would say. So this is very informative, and it's really looking at every day for the last 30 years. So, for example, in this one, you can see how the maximum temperatures fluctuate, change during every month. So you can get to see, for example, in June, in this place, the temperature gets up to almost 36 degrees, but also the maximum temperatures could be around close to zero, maybe close to 4. Then in the middle, without color, you see how the averages move, and then in blue, how the minimums change. So, for example, also in June, you get to see that the minimum temperature um, oscillates from somewhere like 16 degrees to minus 4. But the average of the minimum temperatures are around 3 degrees. So you get to analyze this data and to think, if you're thinking about food production, you can really find information about the plants you want to grow and see if they will work in this climate, and in which will be the growing season for that specific species. And you can also use this for example, home heating. So yeah, really useful and essential information. We also have frost data. So this is how frequent, or the most frequent weeks for the latest frost in the spring, and the earliest frost in the autumn. So in this example, you get to see that the most frequent uh, latest spring frost is in the week 24 of the year, and in the autumn, the most frequent is on the 36. So with that, you can see what's the growing season, which is not very large in this example. In some places with a short growing season, this is crucial to understand when you can grow and when you can take your plants outside, for example. So yeah, in other places where you don't have that growing season that short, or you don't have frost, this is not as essential, but for Canada in general, this is really useful. Then you get the windrows. This is an annual windrows, so you get to see the intensity and the direction of the wind, and this helps plan windbreaks, for example. And we also produce this seasonally, so you can see if you're growing in the summer, you can see the direction of the winds for the summer, and then plan accordingly to that. We also have some energy opportunity layers, so we are very excited about creating these thematic maps for the world. We started with the US and Canada, but we see that these kind of maps that are national can really help people understand what's the best location for the project, because sometimes people are like trying to choose between two different provinces or states, and this information will help compare, at least on the renewable energy opportunities. Yeah, we give you the data about the best place for the project, depending on what you are wanting to do. So this example shows the wind farms in both the US and Canada. So you get to see which areas are used more for wind energy. Also, the solar photovoltaic potential for those two countries, and prices at every state and province. So with this, you see that the province or state you were thinking to move or to create a project, you see maybe the energy is too expensive, but with this other layer, you can see that maybe it's expensive, but there's potential to generate energy with solar panels, and you can compensate that. So basically now you have the information to make informed decisions on this regard, right? We are really excited about this kind of maps and think it's useful for people choosing a location or for designers also working on locations in different areas. Another of the things we have in Regen Tracker is what we call the Pro assessment. So this is really probably where we are giving most of the value to people deciding to purchase a property or trying to diagnose their property for the potential, for both for limitations and potential. And here we assess energy, water, food, and land. So this is very also very exciting because this is where we get to use really the power of GIS tools to combine different layers and give this more easy to understand assessments. So with this, we are not bringing like raw topography layers, for example, that you have to understand, but we do an assessment and then we provide like the highlights. And this is, yeah, we are really also excited about this, and we already see that this is really helping a lot people trying to choose where to buy land, for example, or make decisions about the projects. And I have some examples here. This is a soil map. So where this is available, we are providing soil maps for people to understand the different soil types in the land, which is crucial for planning different things like ponds and agriculture projects, food growing projects. Then this is another map about passive irrigation potential. So this is using topography to understand in which areas you have enough pressure to have irrigation by gravity. So in this map, you can see the white boxes are the buildings, then the pink thing is the existing roads, and the red dots there are the rain tank locations. So if you locate the rain tanks there, you have high pressure in general in the rest of the property, but you can see like the lighter blue section, you get from 4 to 5 psi, which is the pressure, and the darker blue areas get more than 5 psi. So this also helps plan how to move the water. And yeah, by the way, the person who produces these maps is Adrian, who's here at the meeting. So yeah, he's doing an amazing work building these maps and providing lots of value. Another one is the ideal dwelling sites. So not every part of the land will be good for building. Sometimes it's because of the land use by law, but other times it's because some parts are too wet or too close to water. And in this layer, we try to consider multiple aspects and to assess which are the best building locations. So this property already had some buildings, but if they want to consider building more, then we can give like the darker green areas is where we suggest to have other buildings, but we also are checking that the existing buildings are in a good place. Yeah, it's interesting that in a very recent project we did for a client, this layer was key for them to understand if they were purchasing a property or not. And it was a very very high investment on that property. So these kind of layers really can make a decision easier. So that's why we are really happy with the end product. And then there are other layers like this one, checking for risks, for example, fire risk, pollution risk, also frost pockets. So there are some some suggestions to consider in planning, because like risk is always there, I would say, but you can choose for example, for a house, you can choose the less risky area. So yeah, this is also an important one. And there are many more, but I didn't want to like go through all of them. I think it's 13 maps, really combining different layers, as I said, and trying to give all the most important information if you are considering producing food, generating energy, um, locating buildings, and also doing earthworks for water harvesting, for rainwater harvesting, for example. And this is also somewhere where we are improving and building new stuff to really provide a lot of value with these layers. So this is another huge part that I want to go through. The main part of our work is about diagnosing properties, so understanding the characteristics of the land to do a good design. But the other big thing is really monitoring and seeing if a regeneration project is really doing the work that it's supposed to do. So we know there are regenerative practices, and you can have intentions when you design, but we think it's really key to monitor what's happening and really see the outcomes of that work. So we have done a huge investment on time and energy on this aspect, on monitoring ecosystem health. And we have done this in different ways. So there are multiple data sources that you can use to monitor what's happening on the land, from satellites, which is the most far away way to sense something, to having an expert, a human on the land, assessing like very small things like insects or taking soil samples. And in between, you have different things like drones, mobile field sensors, stationary field sensors. And all of these things have advantages and disadvantages, so they are complementary. Satellites are great because you can cover the whole planet very fast, but and with a high frequency, but you don't get the accuracy that you get with a human on the ground. And on the other side, with a human on the ground, you can't cover too much land, and it's difficult to scale. So the frequency you can monitor that is very low. So we have to play with these variables, and we are trying to build a methodology that covers everything from the satellites to the field experts. So I will go through this. We have already included some of this in the current version of Regen Tracker, but are also including very soon the other parts. So for this work, we are using a framework called BORS, developed by Robert Constanza 30 years ago. And this is the most science-backed framework for ecosystem health. And it includes different categories of metrics. One of the categories is vigor, so basically measuring the activity, metabolism, or productivity of the land. Organization, which is the number and diversity of interactions between the components of the system. And resilience, which is the ability to maintain the structure and patterns of behavior in the presence of stress. The S we're adding after BOR it is because we are including also ecosystem services, which is a very common addition in the literature. So you end basically with a standard formula for ecosystem health, including those four sets of metrics. And that's what we are using for specifically for the remote sensing work. So this is one of the charts we are producing for the different projects where we assess the landscape health. So is the ecosystem health applied to the landscape with satellites? And this is an awesome work too, being done by Jason here in the meeting. So yeah, in this property, you can see that the landscape health score is 72%. And then you have the individual categories score, so Vigor, organization, resilience, and services. And organization subdivides into three subcategories, which are heterogeneity, connectivity, important patches connectivity. And all that, yeah, converts into a formula with the health score. We speak about landscape health because this is like a big picture thing. It's at the landscape level. Like with this, we are not assessing how many pollinators you have or some characteristics of the soil, for example. This is what we can get from the satellites, which is more of a big picture thing, which is really useful. And we get to understand like things as health and abundance of vegetation, but also how it is organized, how many natural areas we have, how connected they are, how organic are like the boundaries of the things. So we get many metrics that give us a sense of ecosystem health at this scale. We can go at other scales, and we do, but yeah, this is what we call the landscape health. So with this, which is really interesting, is that we can monitor back in time. So we can go up to 2019, and because the images from the satellites are available since that year, and we can really see the trend of each category and of the whole score. So if it's a regeneration project, we can really show how the trend is moving and if it's improving or not, and which areas are improving more than others. So with this, we get many different charts. Here we are showing the current values, but also the previous year values to see how it changed the last year and if they went up or down, and also the maximum value we had so far in these years. So you get to compare how the work is going. This is for example, for vegetation vigor, where you get to see how it changes over the year and over the years, having very high values in the summer and very low values in the winter because of snow. And yeah, you get to see also how this changes over time. If for example, you are doing a reforestation project, you should see a huge increase in this. You also get to load maps on our web viewer and compare the different years. So you get to see how each area inside the property is doing, like which ones are more healthy or abundant than others, and how they compare year to year. This is another interesting one. So land cover is one of the key parts of land projects. So there is different value on the different land covers. And I mean that it's not the same an area with trees that an area that have crops, annual crops, for example, or built areas, or water areas, or grass areas. So this map shows how the land cover has changed over the last years. So again, if you're doing a reforestation project, you should see how the trees land cover have increased over the years. So yeah, that's there are many more charts. I know Jason probably wanted me to include more here, but we have charts really to see like how every land cover is improving on the different categories. So you see how your forestation projects are improving the vigor, for example, the general vigor, or how your grasslands are doing in that regard. So we have a lot of cool metrics here, but yeah, I include some of them because it's a lot. So yeah, the other thing. So to start, we said, okay, this is a lot of different data sources, and we have to start somewhere. We started with satellite, and we also um, started last year working on the layer 5, which is field assessment by experts. So this is like the standard way of measuring ecosystem health or the health of a property, a farm. So we are working with a team in Argentina and with them we are developing this methodology, like the field part of the methodology, which involves going to the land with a team of experts, ecologists, and assessing the most important metrics. So we have developed this methodology, including all these groups. So we have vegetation, where we assess all like species, not all the species, but we have a methodology where we choose different areas and we assess what are the species and the amount of soil cover, for example, in natural areas, in crops, in grasslands. Then we are also doing ground dwelling arthropods to find insects that are like those insects that walk on the ground. Also pollinators, which is a very sensitive group that really thrives more on regenerative organic agroecology projects than in industrial ones. Birds, which is probably the group, biological group that everyone engaged more. It's really cool to see the impact of these projects on birds evolution of species and like abundance of species and abundance of individuals. So I should have said abundance of individuals and diversity of species. Then amphibians are the same, and soil also using the cache framework developed by the Cornell University. So we developed this prototype of methodology and then tried it in Argentina in 8 farms. We built a team of 14 experts. We spent more than 1,000 hours and covered more than 1,500 hectares, assessing these metrics or these groups of data in organic farms, regenerative farms, and industrial farms. And now we are in the work of doing the data analysis for that to try to understand what are the most relevant metrics and also to try to optimize the methodology. So we really do the most important metrics that gives us the most information. And there are also some exciting things that we tried that I will talk in a few minutes. So this work of going to the land is with experts and doing all these groups is really interesting. Like we get lots of important data, but it's also really, really hard work and difficult to scale. Here you can see images of us putting the pollinator traps. So the pollinator traps It's basically plastic cups from different colors and with a liquid. So insects would come there because they are like pollinators would be attracted to the colors, and they would fall into the water and die there. So that's the standard way of counting the pollinators you have in an area. And we did this in different like crop areas, grasslands, natural areas. So, and then you send that to the lab, and then someone, an expert, would count every insect and recognize every species. That's really hard work. So we are looking for alternatives now, and we'll talk about that in a few minutes. Then, yeah, for birds, we send ornithologists who stay 5 to 10 minutes in one of the points of the property, hearing at the bird sings, but also looking what they see, and then they fill all the list. They have someone helping writing the names of the species they recognize. For frogs, amphibians is similar, but you have to go mostly into the night. And yeah, then you can see also the vegetation team working and the soil team getting samples. So yeah, really interesting work. This is something we will offer to projects that really require a deep understanding of the biodiversity and soil as a good baseline. But for some projects, we will just do the remote sensing stuff. So it depends on the requirements, I guess, of the project. If possible, this is great to do, but it's also more expensive and more work. Then in the middle, we have sensors, and we have mobile sensors and stationary field sensors. So by mobile sensors, that could mean many things, but I will talk about two options, which are phones. So these are things anyone can use. And this is probably one of the most interesting things for anyone working on a regeneration project, because anyone can use this and start learning about their biodiversity. So one of the projects is a naturalist. So with a naturalist, you can take a photo of a plant, and you can also say, okay, I think this is this species, or you can just upload the photo. But then there will be a team of like other people in the platform that will say, okay, I know that plant and this is species. Or maybe they would say, oh, you said that it was some species name, but that's wrong. In reality, this other species. So there is a process there to validate the species you find, and for you to learn also. With this information, they also built an AI model. So now you can take the photo, and in many cases, it will give you the species name automatically. So, and that's really useful. We have tried that. It's super interesting. And that's a really neat way to, if you are even like for rural projects, urban projects, you can go outside with your phone and start taking pictures and learning about the different species. And learning about the different species is key, because we see that people who know about the life forms around them start to be more conscious, start to do better things for the environment. Another really cool piece of that is that this builds the largest database about biodiversity in the whole world. It's available anywhere, and it's open data. So you can access that and see what are the observations in your area. We use this to give people information about the observations in around their properties. So you can see if species that are interesting to you are there. For example, you can see if there are bears in the area, or if there is a specific species of fungi, or if there is a specific type of native plant that you are interested in. So this will depend, the use of this will depend on the project, but this will give you very interesting information about what's available in the area. We also suggest people to use this in their projects. so they can really start building an inventory of the biodiversity they have without requiring a whole team of experts going to the land. So this tool is really, really useful for people interested in the biodiversity in their property or in their area. And another tool, which we are not using in our product, but it's really interesting and useful, is the Merlin app by Cornell University. So this app is for recognizing birds, and it can use photos or sound. So you can uh, get out there and get outside and start recording with the phone, and you will start to see the species of birds that are singing. And if you are building a food forest, for example, it's really neat to start measuring that and see which species you have at the beginning of the project, and also see how that evolves. And then, and this is close to the end of the presentation, the last part is the stationary field sensors. So we have tried some of these, and we are doing more of these next year. So what we tried in Argentina is the sound sensors. These are from Wildlife Acoustics. So this is a sensor you can leave there in different points of the property, and they will record. You can set it up to record every hour, like the whole day, or like 1 hour per day. You can configure it to record at specific times when birds are singing more, and you can leave it there until the batteries don't work anymore. So if you record all the time, that would be like a week. But if you record at specific times or 5 minutes every hour, which is one of the protocols, that would last like more than a month. And with that, you can get a really good inventory of the species in your project. We have already tried this in Argentina. It works really well. And if you have uh, people with the skills to recognize the species by the audio, then this can be even more accurate, or give you more information than sending the experts to the ground. Also, with this, the AI models for recognizing species, bird species, are making progress. So we think this will be one of the most valuable tools to understand birds diversity in the coming years. And you can also get other things from this kind of environmental sound sensors. You can also get information on bats, and even there are some specific sensors that work with insects, but those, I think, the hardware is a little different. But yeah, this is a very exciting field, growing field, and still experimental, but really, really cool thing to see. Something else that we tried in Argentina is soil sound. So this is the same, but you record the sound in a soil sample. And this is even more experimental. There's no commercial products for this. So we had to put together everything to be able to do it. And there we haven't tested this data yet, but there should be a correlation between the life in that soil and the sound metrics that you can get from this. So this is something we will be checking, analyzing the coming months. But it's also exciting as an easier to do soil metric. And then this is what we are getting into right now, and next year and next years. So as I said before, for the pollinators, the conventional traps have liquid where they would die for us to be able to count them. So, and it's also like really hard work and not very scalable because you have to send that to the lab, and it takes a lot of time. So these kind of sensors, also have colors, but instead of the liquid, they have cameras, and they can take photos of the insects when they come, and they don't, yeah, basically they don't die. And you can have real-time information about the insect that you have, the abundance, diversity. And so this is something we want to try next year, and we are working on a grant to applying to a grant to start building this. And so we are at this moment we're looking for partnerships, like working with other organizations to put together a project. So if anyone is interested in this, we would be great to have a chat about it. We will try these pollinators sensors at different places. So it could be a good opportunity to collaborate. And I think, yeah, that's all. So that's the whole data set that we are offering with this product Regen Tracker. And this is the way we are helping the consultants at Fifth World, but also outside from Fifth World to work on regeneration projects, giving these inputs for their work, but also giving these monitoring tools for them to be able to track the projects, to show how good the projects are doing to our people. And for example, one of the exciting collaborations we are looking forward in the next months is with a consultant working in Africa for um, regenerating mine areas. So this kind of tool can give him can show organizations involved in those kind of projects how things really can improve and can evolve. So yeah, happy to hear the questions and to start the discussion. And I saw there were a lot of things in the chat, but I was not able to read.
Thank you so much, Danilo. Yeah, I think there was a couple of questions that got mentioned there in the chat. Let me go ahead and pull some of those up. In the meantime, if anybody has any questions for Danilo, go ahead and feel free. You should be able to unmute yourself. And yeah, ask any questions you have.
Well, I always have questions. Thanks for the presentation. It was really exciting to see the stuff that you're building and using for Fifth World. I'm wondering, do you see a potential down the road to make these products available, for sale? Or is it more sharing them with people? I don't know how much is proprietary and et cetera.
Yeah, that's a good question. So these products are for sale currently. Actually, we launched, I think, a week ago. So you can find it on regentracker.com. So we have that, but at this moment, because it's still very early for us, we are also looking for like collaborations, exciting projects. So we are also excited about seeing how these ecosystem health metrics, the satellite ones, work in regeneration projects. So we could be able to collaborate if there is a regeneration project that has started, for example, in 2019, and they want to track how this changed according to our metrics. We would probably be happy to collaborate on that and get to try the metrics, to get feedback from you. So we really think collaboration is key. This is a very large challenge to be able to track these things, and we really like collaboration. For example, these sensors that I mentioned, the pollinator sensors, those are open source, and we will keep them open source. We will do some improvements, so we want to add sound recording to the same sensors and maybe some other things, and we want to keep them open source because we think if we can help projects get more data on biodiversity, that's like would be awesome. So, I mean, it is a commercial product, but we are open to discussions and collaboration.
Great, thank you.
Thank you.
Yeah, so there was a question
Any
that came
questions?
from Joshua who had to hop off a little early, but I'm sure will be appreciative of me asking this because he'll most certainly watch the recording later. What value are users able to generate for you through this new platform? Will you be able to generate reports on what specific regions or data sets users are exploring? It would be interesting to see what users are actually finding interesting in terms of the data sets.
Okay, so one of the parts of the question was where is this available? So it's for sure available in the US and Canada. For example, the energy layers are only available there, but we are also considering other areas and expanding to other areas. So if you have a project somewhere else, we can, I mean, let us know and we can see what we can do. And yeah, we will tell you if we are able to do it or not. Some things like the ecosystem health monitoring is we are using satellites that cover the whole planet. So it should be available everywhere. There are other things which are harder to find, like soil data. In some places, is not that good, or elevation data. In some places, it doesn't have a good resolution. We already have some alternatives. In the example I show in the screenshots, we're using LiDAR data, which is ideal. In some countries, that's not available, but we have some alternatives, so we can still do it. But we have to check for the specific region. So that was one of the parts of the question. The other part was more about where the clients are finding most of the value. Was that the question?
Yeah, basically, like, what are you going to be able to generate reports on specific regions or data sets users are exploring? And then the other part of it was what value are users able to generate for you through this platform? I think they're also curious about like which sets of data are the users finding to be most helpful or most interested in.
Okay, so I would say this is really early for us. So we started last week, have made some packages, but not many to have like statistics and that or really good data. But I would say because there is also some history of like this, there has been like earlier prototypes and stuff. So I would say at one side that the topography layer is like the essential thing. It's like if you need one thing to start, that's probably it. And then I think currently the most of the value we're providing is in those pro assessment layers, because that's where we get like a professional, like a consultant on land design to really analyze the data and get the highlights right. Like we give them a report with opportunities, challenges. So that's more digested for users who may not be experts on this. So that's probably where we give the most value to them. So I hope that answers the question.
Yeah, I think so. Does anybody else have any other questions as I'm scanning through the chat and looking for any other questions that might have popped up along the way here? Again, feel free to go ahead and unmute yourself. Otherwise, I'm sure I have some questions that I could ask, but I'll give space for others to have the opportunity. Danilo, Could you you mentioned in the organization component of the pie that you were showing earlier, you mentioned heterogeneity, connectivity, and important patches connectivity. Um, Perhaps you could double click a bit on that and what those are and how it relates.
Yeah, yeah, I think that's great. And I think that's also great that we have Jason in the room, because he's really like the expert on this part. He has been developing this, and Jason has incredible skills on remote sensing, GIS stuff, and science in general. So maybe Jason, it would be great if you can share a bit about those.
Sure. Thank you, Danilo. Can you hear me well? Right. Yeah, so as Danilo presented, the landscape health scoring takes into account 4 components. Vigor, so we said that's the activity of the vegetation, organization, resilience, and services. So for organization, what we do is trying to get a detailed picture of the landscape. So for that, we're taking the 6 years of data, remote sensing data, to classify the landscape from 2019 to now. So we're trying to get to say each pixel is part of one category, and this pixel could evolve through years, or it might remain the same. But the idea is to get that mosaic. So generally, there are a few classes. I would say 5 to 10, 12, depends how diverse is the landscape. And once we have that picture, for the human eye, it's difficult to quantify things. We can see that we have a few patches, probably, for example, of forests that are here and there, not necessarily connected. What we want to do here is quantify that more accurately. And well, there's honestly almost an infinite number of metrics you can get, but there are a few common ones, and they can be categorized in a few main category. The first one I would say is the complexity of the shapes in your landscape. For example, if you have just square plots for agriculture, this might not be great for supporting the biodiversity and or all the edge effects that you will have between one land cover and another. So there's that category, the shape complexity, and actually one metric within that is scored in the heterogeneity. And another one, another category related to that will be the core habitable area of each class. So if you have only very small patches, for example, just patches of trees are like 15-meter wide, for example, it's not really a forest. You won't have much biodiversity in there as well. So there are some metrics related to that, like for that class or the landscape in general, can we consider the patches to be habitable to really create a livable environment for whatever species? And then we have connectivity between all similar patches. And Danilo mentioned one part is focused on the important patches. This could be variable from one property to another, but by default, we consider that's the forest patches. This is where the life is more thriving. So we want to focus on all those patches of trees are connected. And of course, it might depend on the kind of what's the word? Different biodiversity group. You could focus on big mammals, on birds, on insects, and of course the distance they can walk, fly, whatever is different. So we can take that into account. And well, of course, there's the diversity that is scored, and how even is the landscape. Is it a real diversity, or is it like 90% one class and the other class are just representing a few pixels? So in that package so far, what we're bringing to potential customers or our consultants is what are the trends for those metrics? Like, is the landscape evolving to being more fragmented, or getting a bit more complex or diverse, etc.? So I hope that answered the question.
Beautifully. Thank you so much, Jason.
Welcome.
All right. Any other questions? I may have missed one in the chat, but I'm not currently seeing it. That's that one, but yeah, if anybody else has any questions, feel free to unmute yourself.
Well, Ben, maybe I will add something about the mosaic I just said, because that mosaic description is critical to assess how organized is the landscape, but it's also a very good start to then investigate which parts separately. Like we mentioned the vigor, so we can score the wall property in terms of how active it is, but then we can focus on each of the classes we detected and see which one contributes to the overall activity and identify areas of improvement. So you can also focus on one class and you'll know what it is on your property. You know that corresponds to some kind of trees, for example, or a crop. And you can see how it evolved throughout the years. Like, is it getting more vigorous, sorry, or less, or is it expanding? And then you can, well, identify the strength and weaknesses, and well, support them or trying to reverse a bad trend. All the other things.
Yeah, I find it incredibly fascinating. This is for those of you that maybe are familiar with Rob Avis, he has talked about a whoop for planet Earth. In fact, when V DAO was at East Denver and had a conversation, did a panel with Joe Lubin, kind of the unveiling of V DAO, if you will. He actually had mentioned, I think it was the first time I heard him mention about a whoop for planet Earth, or like a Fitbit for planet Earth. And this, essentially, it sounds like this provides a sort of feedback loop that allows you to start optimizing once it's in place, to really key in on the areas that maybe are not producing as well, and kind of dig in and see why that might be, and how you can implement different measures to enhance productivity. Is that fair enough to say?
Exactly. Yeah, that's the goal.
Yeah, this is like, it gets me really excited. I think it's really, really cool to like have this as a tool and it's cool to see all the different data sets and how it's presented. And Danilo, you did a great job of like going over each map and kind of doing a good job of explaining you know, what each one is representational of and what it's trying to tell us. This brings up another question for me. It's around how does this sort of system, or systems like this, reflect in terms of cost savings to a land designer or somebody who's looking at establishing a regenerative property, or just looking at a property from the standpoint of like, I want to turn it into a homestead, but there's like several options right in front of me and I don't know which one to go with. How does this data and a tool like this help that individual and actually turn it into a cost-saving decision for them?
Yeah. So when you say you have multiple options, you mean multiple property options or multiple management options?
I
Like
think
things you can do.
I think both could apply, right? I
Yeah.
think both could easily apply here.
Yeah, sure. So if you have multiple properties, like that's how one of the ways that people is already using Regen Tracker, like to assess, okay, I want to move to a rural property to grow my own food, to have a food forest, and like does this piece of land have enough sun, for example? Does it have enough hours of sun to have a food forest? Maybe yes, but to have solar panels, for example. And that's one of the cool tools that the team have been, actually Adrian and Jason have been developing very useful tools to develop, to understand the amount of hours of sun we have at every pixel of the land. So those kind of things can help you understand if a property is good for your project or no. Other kind of things is like water availability. If you want to grow food, you need water, but does the property have enough water? Or the ability to capture enough water. So for selecting a property, it gives you a really good diagnosis of or data about what you can do there. That's one thing, but then also if you already have the property and you are deciding about how you want to manage that, so that's a harder question, I guess. The intention of this tool is that it will give you information on how each, like if you have different land uses for your project, this will give you information about how the health of each land use is evolving. But there are also other variables, like you will want to see vegetation bigger, for example, increasing, but there are other things like, for example, what's the function of the food forest? Is it to, if it's to regenerate the ecosystem, maybe that metrics is enough. But if you have other functions like producing a specific type of food, then you have also that metric, like, are you really able to produce that? So I guess this tool helps on give you like outcomes at the landscape level, but also you will have your metrics regarding like your harvest, for example, which you can combine to go where you want to go. And one of the things we will be working or we are considering working on next month is to be able to kind of simulate what would happen if you put a forest in this project, how the metrics would change. Or if you instead of doing a forest, you put livestock and grasslands. So those kind of simulations would really help you decide what would be best for each property. But that's not something we already have, but we are excited to work on that. So there's a huge potential with this tool, but this is the first step. And yeah, really looking forward to continue with those other steps and to continue evolving the tool to give the most value to the people regenerating the land, basically.
Danilo, can I add one quick thing?
Yeah, sure.
There's a saying in permaculture as well, in that work is a failure in design, which I think in many regards is really quite true. And so what the Regen Tracker is going to do, both for property owners as well as designers, it's going to be kind of like a first major step in the site assessment process to come up with a design that it's actually relevant to the site, and it takes into account sort of the peculiarities of that site, because those are some of the things that, if missed, can create errors. It can create sort of cascading issues that in many cases can be actually quite costly to solve. So I think another dimension to the answer to the question as well is like, how much money are you going to actually avoid having to spend by having a good picture of the site, and then to be able to actually walk onto your site with really good information, and know where to look further on the site to come up with a very relevant response in designing that site that will last a really long time and minimize costly errors.
Yeah, exactly. Great addition. Thank you, Adrian. That's the whole goal of Regen Tracker, like helping you make the best decisions.
Yeah, I love it. It's a tool that allows you to work with the best uses of the land, and help you avoid making costly bad decisions based on a lack of data. Like I mean, I forget who it was I had chatted with, but the name sorry, the name it escapes me, but they were talking about how they were working on their property, tried to implement, I think it was a pond, and it turned out that the pond was not in a very ideal location, and kept draining, and subsequently they had to keep refilling it artificially because it wasn't in the prime location for any like melt or runoff or anything to continuously fill it. And it turned out to be an extremely costly mistake. And so something like the Regen Tracker, or tools like this would allow you to make a more informed decision to avoid such a costly error. So I mean, that in itself is a great value. But also the ability to tap into the abundance that nature can offer just by working with the land rather than trying to, you know, force your own will upon it. It is again, it's amazing. So very cool. All right. Is there any other questions, comments, feedback, ideas? Anything out there that anybody wants to throw out there? Just checking the chat real quick one more time. Yeah, if not, just want to say thank you to everybody that came today. Thank you, Danilo, for taking the time out of your day to, you know, educate us on, you know, not just a Regen Tracker, but like how important it is to have that data available to you, to make these smarter, most likely cost-saving decisions, that actually allow us to work with the land rather than try to, you know, implement our own will upon it. Yeah, just huge thank you to all of you. And Adrian, it's always great to hear from you, and Jason, you as well. Thank you for also stepping in and answering a few of the questions that I had. Super helpful. Thank you.
Yeah, and thank you, Ben, for organizing this, and V DAO, all the team, because what you're doing is really exciting. I'm looking forward to be more active next year on the chat. I already ran a local meetup, and it was exciting to hear from people and to share the ideas behind V DAO. So yeah, really looking forward to 2025 and what will happen at V DAO.
Yeah, we're excited to see what Uruguay does in the future. As maybe some of the folks that are joining in or listening to the recording weren't aware, but Danilo had a V community meetup down in Salto, Uruguay, just a couple weeks ago, very recently.
Yeah.
It sounded like it went really well, and yeah, if there's any opportunity to have another one down there, we would definitely want to be able to support that and continue that effort down there. And if anybody has any questions about having or hosting a V community meetup, you can reach out to anybody that's in the DAO. But specifically, if you want, you can reach out to me. Yeah, happy to answer any questions around that and support those efforts. But yeah, again, huge thank you. It's been amazing. Really looking forward to next year, 2025. This is actually the last virtual event of 2024. So I hope everybody has a wonderful holidays and an amazing start to their new year. The next virtual event that we'll be doing will be actually a community call, January 14th. So looking forward to that. And then of course there will be a continuance of these virtual events starting again thereafter on a weekly basis again. So very excited.
Thanks, Ben. Thanks, Danilo, Jason. Really good.
Thank you, everybody.